In this video, we're going to have a look at fractions, namely some multiplying fractions, but then we get into a nice discussion about what prime numbers are and how prime numbers are related to greatest common factor and how greatest common factor helps us to simplify fractions into their simplest form, which is also called lowest terms, or the most reduced fraction. That's today on High Peak Education. What's going on, everybody? Hope you're having a great day. Thanks for watching, and in this video we're going to get into some basic mathematics which kind of will help you get ready for fractions, but hopefully you'll understand numbers better by having a look at prime numbers, greatest common factor, and how to get the most reduced fraction. So let's have a look at today's content. To multiply fractions, we multiply across. 2 times 5, 3 times 7 gets 10 over 21. But notice that this is already in the most simplified form. Now, we'll come back to that in just a moment and prove why that is. But it's because this fraction, 10 over 21, it has different properties compared to 2 over 4. So you're saying that if you take half of 2 and then half of 4, you get 1 over 2. Let me ask you this question, and sometimes people use this terminology. What is the GCF of 2 and 4? Now, what do I mean by GCF? Good, greatest common factor. So that's something that you should be aware of. In a slightly different way, we're going to use that concept in algebra. So just know that, we're going to use this. Greatest common factor. It done, so you can see that. So the greatest common factor is the GCF. So if I write this little ditty, if I write GCF of these two numbers, 2, 4, what is the greatest common factor of those two numbers? Okay, so let's talk about this. This is an important idea. So again, this sometimes gets glossed over in middle school or early high school math, but I want to make sure it's clear. 2 is what sort of a number? Prime or composite? So let's define prime versus composite. A prime only has two factors. And what are those two factors? So it's going to be itself and 1. Itself and 1. Let me give you another example. So take the number 7. 7 is prime. How do I know that? Well, if I have 7 things, let me just put a couple dots here, right? 7 dots. Can I make 2 basketball teams out of 7 people? No, it's not possible, right? You have 3 on one, 4 on the other. Can I make teams of 3? Or 3 teams? No, it's not possible, right? It turns out you can keep going through this. 7 divided by any number you can think of is a decimal. It's not a whole number, right?
Okay, that makes sense.
That's what it means to be prime. So 7 is prime, and that's because, so you cannot divide 7 by any number you can think of and get another whole number. You cannot divide 7 by get another whole number, right? You're going to have extra, or you're going to have a remainder, or you're going to have a decimal, right? Those are all things you've heard of before or seen before, right?
Yeah.
But the thing is, when something is a factor, that means it divides evenly, right? It divides evenly. Let's take the number 6. 6 has 2 factors. Aside from itself and 1, which, by the way, every number does, right? Take the number 17. 17's prime as well. 1 times 17 is still 17, but no other number goes into it, okay? But 6 has 2 factors, because 6 is not prime. And what's the term we were just using a minute ago when 6 is not prime? Composite, okay? So think about what the word composite means. Do you know what the composite of 2 images is? The composite of 2 images, you lay 2 images on top of each other. So there are 2 components. You ever see an image of many frames of a cheetah running across the savannah or whatever? it almost looks like an animation, but it's one image.
Yeah.
That would be a composite, because I guarantee the person took several photos with a high-speed camera and they just laid them out next to each other and then put them on the same image.
Got it.
So a composite means it's made up of many parts.
Okay.
Now with numbers, the parts are just called factors, which they divide evenly. So can you tell me, aside from 6 and 1, 6 is what other numbers multiplied by each other?
2 and 3.
2 and 3. So that's how we know 6 is composite, because it's 2 times 3. Does that make sense? Now, by the way, this kind of thing I'm doing right here with the little branches, we often call this a factor tree.
Okay.
It's just a fancy way of saying, you know, let it go as far down as possible. And by the way, everything on the bottom of a tree must be prime. Can you see all that? And then, so this is called a factor tree because, again, all the things at the bottom are prime numbers.
Okay.
Because the tree stops once you hit a prime number. You can't, it's not composite anymore, right?
Yeah.
You follow what I'm saying? Okay. So now let's think about the greatest common factor of 2 and 4. 2 we know is prime. Now, by the way, let me just list out a few prime numbers for you that you should be aware of. Some of the easiest prime numbers. 1, 2, 3, 5, 7, 11, 13, 17, and then so on. Because think about it. Can you take a group of 5 and split it into 2 halves? Not possible, right? You either need like a team of 2 and a team of 3, or like 2 teams of 2 and 1 person gets left out.
Yeah.
Not possible, right? Okay. Same with 7 or 11 or 13, right? I mean, can you take 13 divided by 9? No, right? It's not possible. Okay? So prime, now the thing is, very few numbers are prime, but the prime numbers are unique. By the way, another way to think about the prime numbers is that think about it this way. These numbers never, ever appear on the multiplication table. So when you were learning your times tables, did you ever see an 11 or a 13 on there? Not unless it was 11 times 1. That was like the only exception. Other than that, it's not on there.
Got it.
Right?
Yeah.
12, let's think about it. 12 is 4 times 3, right?
Yeah.
12 is 6 times 2, right? Okay, so 12 is composite. Let's take 10. 10 is 5 times 2, right? Or 2 times 5. Or 10 times 1, but you know, let's take numbers that's not multiplying by 1. But I don't think 11 appears on there, right? 10 does, 12 does, but not 11. And also not 13. Right?
Okay.
You see what I'm saying? Prime numbers are unique. Prime numbers are very unique. Okay. Now the reason I mention all this is because if we already know 2 is prime, there's no need to do like a tree for it. But 4 is composite. By the way, 4 in the list of numbers, do you see how 4 is the first number missing here? 4 is the first composite number. So 4 is what times what, aside from 4 times 1? 2 times 2. So 4 is 2 times 2. Think about this. This is an important idea. Now listen carefully. Do you see that 2 and 4 share one prime number? That number they share is the number 2. Now this is what's important. Couldn't you take 2 over 4 and divide by the greatest common factor, which is 2, and get the same thing that you got here, 1/2?
Okay, yeah.
So that's in some sense a faster way. The faster way is figure out what the greatest common factor is between both numbers, and then you get the most reduced fraction.
Okay.
Now, by the way, a couple quick thoughts about this. First of all, it's not always necessarily obvious what the greatest common factor is. Let's try another example where the greatest common factor is a little more obvious. Let's try if we have, say, 3/9. So what's the greatest common factor of 3, and 9. So is 3 prime, by the way? Is 3 in the list?
Yes.
Yeah, 'cause it's such a small number and you can't cut 3 in half or anything like that, okay? So 3 is in the list. Now 9, consider the little tree. What would 9 break down into since it's composite? Yeah.
3 and 3.
Yeah, 3 and 3. See that? Now, if 3 and 3, do you notice that these two, just as before, what did they share? They share 1, 3. Just 1, 3. So we can divide the top by 3 and the bottom by 3. And then what do we get as far as the most reduced fraction? Exactly, we get 1/3. Okay, so we get 1 over 3. Now notice, 1 is prime for the top, the numerator, and 3 is prime. So we know we're done, okay?
Prime for you to like be done? Is that
Great question. Not necessarily, but when they are, you know you are done. So let's actually write that down. So how do we know that a fraction is in the most reduced form? Okay, it's a good question. How do we know a fraction is in the most reduced form? Okay, let's see if we can answer this. So, one way to know is that both the numerator and the denominator are, and this is important, both prime numbers. Think about this. If they're both prime numbers, nothing goes into them except themselves and 1, and so that's kind of the idea, right? So, because think about it, right? You may say, oh, what if you have 3 over 7? Well, we're done, right? Because 3 isn't going to go into 7. Nothing does, okay? Okay, because 3 is prime as well. Okay? So if they're both prime numbers, then you know you're done.
okay?
The second thing is, if you are certain you have already divided out all the factors. Okay? Now, by the way, if you know you've divided out already all the, and by the way, when I say all the factors, shared factors. Did you notice down each of the last 2 problems, I was circling in purple the number they share? Right? The thing is, in order to find the greatest common factor, you need all the numbers they share. And then you divide by that. Okay? So if you've divided out all the shared factors, you're done.
Okay.
The other way to know is this, and this is another kind of way to know. If the numerator is prime, the only way the fraction can still be simplified is if the numerator itself is a factor of the denominator that remains. Okay? So those are basically your 3 rules. So basically what I'm trying to say is the reason we know we're done here is because we're in situation 1. 1 and 3 are both prime. In the same way on the previous slide, this is situation 1, right? Both 1 and 2 are prime. You agree with that?
Yeah.
So we know we're done. How about situation 2? If you've already divided out all the shared factors. Now this is what I was going to work on with you. Let's try situation 2. Situation 2, why don't we try 6 over 30, okay? Now, they're both composite numbers, and they both have multiple factors that they share. Okay? So guess what we need to do? We need to do a tree for 6, and we need to do a tree for 30. And remember, these are called prime factorization trees, right? As far as I know, this is the best way to break down and understand any number. So 6 is what times what? 2 times 3. Do we need to go any further, or are those prime? Those are prime. Prime. So these are done. Okay? So we're all done on the 6. 30. Now, by the way, with 30, as long as you don't start off with the number and 1, you can start off however way you want. So the great thing about the trees is you can start however you want, as long as you get down to primes. That works. 10 times 3. Now, let's look at the 3 branch. Is the 3 branch done?
Yes.
It is done because it's prime. So we'll just stop on that branch. But how about the 10? Is it done? It is not. Because 10 is what times what? It's okay. I don't need. I would agree. 5 and 2. So let's do 5. Okay. Now here's what's amazing. You ready for this? Do you see how these share 2 factors? They share both the 2 and the what? And the 3. So here's the point. The point is, if you look at this fraction and you say, okay, I want to get this fraction in lowest terms, you might consider saying, oh, well, 6 and 30, they're both even. So I'll just divide by 2. Maybe I'll be done. Now notice that would be using just the 2's, okay? So you'd just be using what's in the circles, right? You haven't quite used what's in the squares yet. We'll get to that in a second. But what happens when you divide 6 by 2? Yeah, what is 6 divided by 2? We said that 2 is a factor of both 6 and 30 because they're both even, right? So that's kind of where we were at. So if we divide 6 by 2, and if we divide 30 by 2, what would we get? 15. Good. Now notice, because of the trees, do you see that we're still not done? Because we are tipped off by the 3 there. Now, by the way, one more thing. If you did 3 and 15, do you see that you'd then be in situation 3? Situation 3 above says if the numerator is prime, which it is, 3. The only way the fraction still needs to be simplified is if the numerator is a factor of the denominator that remains. Is 3 a factor of 15? 3 times what gives 15?
Oh, 5.
Right, 5. Now, by the way, here's one way to know that. Listen to me carefully. Watch the screen. If you're not sure what 3 multiplies to get 15, you know where it is? It's right here.
Oh.
Because it's in the tree, right?
Yeah.
Because remember, like, think of 30 as like having a skeletal system, a muscular system, and like a circulatory system, right? 3 is the skeletal system, 2 is the muscular system, and then 5 is the circulatory system, right?
Yeah.
Now, I'm no biologist, but my understanding is that certain animals are like more complex than others. So I'm going to say not every living organism is going to have like the same number of body systems, right?
Yeah.
So when something gets more complex, it just has more components to it. Would you agree?
Yeah.
Use that same thinking with numbers.
Okay.
30 has another 5 compared to 6. They both have 2 and 3, but 30 has an extra 5 as a factor. You see what I'm saying?
Yeah.
So think of factors like body systems, right? Skeletal, muscular, circulatory, whatever you want to do. Okay?
Okay.
Because they all make up the whole, right?
Mhm.
Like, I need several of these body systems to make up my body, right? But in any case, what I'm getting at is the reason you know that 5 is what emerges is because if you still divide by 3, you're going to get 15 divided by 3 should be 5, which is the other number left in the tree. So let's do that. Now let's divide by 3, divide by 3, right? And what's 3 divided by 3?
1.
Yes. And then 15 divided by
5.
5. So 1/5 would be the answer. Situation 3, let me just make a quick comment about situation 3. Suppose you had 7 for the numerator. If you had 28 for the denominator, you would not be done because you could get 1/4 out of that, right? 7 divided by 7 is 1. 28 divided by 7 is 4. But if the numerator is prime, you know you're done if it's not a factor of the denominator. So if you had 7 over 30, Is 30 on the multiplication table for 7?
No.
No, because you go 7, 14, 21, 28, 35. You skip right past it. So this one is done. You see what I'm getting at?
Yeah.
If the numerator's prime, as long as it's not a factor of the denominator, you're done.
Okay.
You follow what I'm saying?
Yeah.
Okay. So 1/4 is done because, oh, and by the way, 1/4 illustrates that as well. 4 is actually a composite number, right?
Yes.
But 1 is the first prime number, which is a factor of everything. So we're just done. See how that works?
Yeah.
Okay. Now, one more thing. We had to go by dividing by 2 and then dividing by 3 to get down to 1/5, right?
Yeah.
From 6 and 30. So let's go on to the next slide and just, now that we are a little bit more educated about this, let's go faster in terms of this is the faster way to do it. The more advanced way once you know this stuff. The more advanced way is this. You know 6 breaks down into 2 times 3. You know 30 breaks down into, just like you said, 10 and 3, and then 5 and 2.
Okay.
So again, this is shared with this, and then these are shared with these. I want to ask this question. What's the greatest common factor then of 6 and 30? So it's not going to only be 2, and it's not going to only be 3. It's actually going to be 2 times 3, which is what number? 6. And again, because 6 equals 2 times 3. It's like saying, look, both of these organisms share a skeletal system and a muscular system. So we might as well just multiply them together. It's like putting both body systems together.
Yeah.
And how do you do that in math? You multiply.
Okay.
Now consider this. Look how much easier this is if we do it this way. If you have 6 over 30, and let's do now the greatest common factor. And by the way, now that we have the greatest common factor, let's choose a different color. So let's call this now in orange. Okay, so we're going to do the greatest common factor is 6. Let's divide both by 6.
Okay.
If you divide by the greatest common factor at first, you're going to be done right away. Because what's 6 divided by 6? What's 30 divided by 6?
5.
We're done.
Oh.
You see what I mean? It's faster if you can identify what the greatest common factor is. Now, as I mentioned a few minutes ago, the greatest common factor is not always obvious. I can't necessarily always look at 2 numbers and say, oh, this is the greatest common factor. Like, sometimes the numbers are big, or if I'm not on my game that day, I don't know. I don't always do it. But the way to be sure of what the greatest common factor always is to do the trees and then find what all the things shared are on the bottom. Because whatever they share together, that must be the greatest common factor. Okay, let's try one more example. 12 over 20. Now, if we want 12 over 20 in lowest terms, here's my question. If we wanted to do this fastest, we'd need the what? Right, so let's start with the tree. Yeah, so let's start with the tree. Whoops, let me put the 12 here and here. And remember, we can start off the tree however we want, as long as we don't start it with 1. I like that.
And then for 20.
Well, hang on a second. Is 4 done on the 12 though? Good with that?
What?
Are you good with that?
Yeah.
Okay. How about 20? It can't be 20 times 1. That's the only thing it can't be. Yep. 10 times 2 is fine.
And then
It's prime.
and then 10 is like we do 5 times 2.
Like it. Good. All right. Now, here's where the magic happens. What is shared between both of these numbers? Yes, but not just 1, 2. Why don't we circle them both? You see that?
Yeah.
It is possible to share 2 of the same prime number.
Okay.
You see that? That's not entirely possible, right? Which, by the way, then let's write down what is our greatest common factor. Well, our greatest common factor of 12 and 20 is going to be 2 times 2, which is what number? 4. Now let your brain think for a second. Can you divide 4 into 12 evenly, without remainder, without a decimal? Yes, you can. Can you divide 4 into 20 without remainder, without a decimal?
Yes.
Yes, you can. And when you do that, what happens? 12 divided by 4 is what? And here's the deal, before we finish, do you see that the 3 was right there?
Yeah.
It was right there the whole time, right? Because
Yeah.
4 is just, see how the 4 was like the 2 times 2? Right?
Yeah.
Like it's almost like hidden in plain sight.
Uh-huh.
Oh, it's right there. I see it. 20 divided by 4 is what? Do you see how that was hidden in plain sight as well?
Yeah.
So 3/5 is our answer, right? 3 is prime, 5 is prime, we're done. So that's how you reduce fractions, okay?
Okay. Alright.
So reducing fractions is a very important skill. I would say reducing fractions is a skill that's kind of almost with number 4 here when we compare and identify fractions. So you and I have done just a little bit on multiplying fractions today here, but then we do have to be able to simplify fractions at the end to know if we're done. So hopefully you had a chance to see what it really takes to simplify composite numbers. That is, taking numbers and factoring them into their prime factors, using those prime factorization trees, and getting numbers broken down into their components. This is a really good way to deal with numbers and to understand their parts and their components, and thus be able to simplify fractions, get them in lowest terms, and then move forward from there. So just to understand that as it relates to number theory and moving forward in fractions, this is a key skill that you'll need when it comes to getting fractions in the easiest to understand fraction form. So hopefully this video has helped you to understand how to know what the greatest common factor is and what prime numbers are. So thank you for watching High Peak Education. Let us know in the comments how you're going to use this when you're dealing with fractions out there in the real world, because all of us will deal with fractions at one point or another. Please smash that like button if you enjoy this content. Please subscribe to the channel in order to grow the channel. Social media links are down in the description below. Please support us on Patreon, and thank you very much for your attention. I will see you in the next video.